All right, welcome back. So we're doing 3-2. We're working towards solving using factoring a GCF when you're doing literal equations. So we're going to take a look at first just multiplying polynomials and monomials together. So if you remember the rule, right, multiply the coefficients, those numbers in front, add the exponents to the same letter, and then write them as a single monomial. So here we have -6 times 8 times -2. So this is 48. -48 times -2, that's positive 96. And then I have 4x's plus 3x's, which is 7, and then minus 2, so there's going to be 5x's. I have 7x's. I'm going to take away 2, right? Those are minus 2, so that's 5. And then that's all I have, so that's x to the 5th. All right. Nope. How about, yeah. 7, okay, there we go. Oh, and then we have 7 minus 2 plus 4. So this actually should be y to the 9th. And then I don't have any z's here, and I have 3 of them there, so I'm left with z cubed. And there's my final answer. Okay, take a look at number 2. I got 6x cubed. We're going to multiply, and then we're going to subtract. So we multiply these two together first. So 6 times 2, -2 is -12. There's 5 x's altogether, 3 and 2, we add them together. And there's just y cubed, there's an in here, so it's just y cubed. And then minus, and here we have the multiply here, so that's 8. Remember, if there's just an x, the exponent's 1, so it's 1 and 4 gives me 5 x's, x to the 5th, y cubed. And then these are like terms because they both have the same letters with the same exponents. So even though there's two variables there, we can add them together. And then 8 minus 12 is going to be -12 minus 8, which you can think of as plus a negative if you want. Same sign, okay? Add them together and keep the sign. So -20 x to the 5th y cubed. All right? And that's going to be answer to that one. I'm going to try to focus this a little bit better. Hopefully this works. Or not. Okay. That seemed to do it. All right, let's see if that works. Okay. So number 3, a little bit tougher. All right. So we're going to combine these, and then we're subtracting in the middle here. All right. Well, actually, we just have a minus here. So times, this is crazy. I'm going to fix this. So I'll change this. This is going to be times in your paper as well. All right. So we're going to be multiplying and then subtracting. So we got -6 times -2 times 3. So this is positive 12 times 3 is going to be 36. Okay. We have an x here. We have 8 of them. No x's, and then 4. So that's 12 x's altogether. All right. There's 3 y's here. There's 4 here. That's 7. And then take a 1. So that leaves 6. All right. Then we're going to multiply together here. So we have minus. We have 2 times 4 times 3. That's 8. Times 3 is 24. We have x here. So 4, 3 is 7. Minus 5 leaves us with 2. And now we have z's, right? So we have 2 here, 6 there. So that leaves us with 8. And these are not like terms because although they both have x's, this one has a y and this doesn't, this one has a z and this doesn't. So those are not like terms as we work through here. All right. So that's it. That's as far as we can take it, and that's our final answer. Okay. So multiplying polynomials. So when we multiply polynomials, right, using distributive property, remember we're going to take the number out front, this 3, and we're going to multiply it to each term inside that parentheses, inside that quantity. So 3 times 8 is 24, and there's x, 3 times -6, -18, and that's standard form, okay? If the question says to multiply these two things together, remember that this is a quantity, so this has to go in parentheses, okay? And then we distribute the 3x cubed in, all right? So it's really 3x cubed times 9x squared, and then 3x cubed times 6x to the 7th, all right? And then once again, we're going to multiply. Add the exponents, okay, multiply, so this is going to be 18, add the exponents, 10, and if we were technically listing this in standard form, we want the 10 first, and then the 5 after. And so this is a 10th degree, right? Highest exponent, binomial, two terms, leading coefficient of 10. Okay, so here we go. So distribute. So 6 times 3 is 18. 4 plus 9 is 13. Minus 6 times negative 5 is negative 30, so minus 30. And then we have 4 and 7 is x to the 11th. Okay, same thing here. So distribute. So this is 6x to the third. 3x times negative 5 is negative 15. Both of these exponents, remember, are 1, so that's x squared. And then 3 times 2 is 6 with the x. All right, there's the first page. Okay, so now we're going to do the opposite of what we just did. So if you remember here, all right, we distributed through. Now we're going to work backwards. So we're going to factor with what's called a GCF. All right, actually, this is the second page. There's more here. Skip the page. Forgot I did 2 pages. All right, so let's keep going. So we distribute. So 6 times 2 is 12. There's 7 x's, okay? And then there's 7 y's, 4 y's. There we go. And then it's 6 times negative 5 is negative 30. There's 6 x's here, and then 6 y's. All right, 6 times, and then remember this coefficient there's in there is a 1, so that's just 6. There's 6 x's, and then there's 5 y's. All right, no like terms, and we're good to go. Okay, on to the next one. So distribute. So we have 7 times 12, which is 84. We have x's, there's 11 of them now. 9 minus 2, there's 7 y's. 5 minus 5, that's just going to go away. That's literally going to actually make this is either 0. Remember, though, that this actually turns into just 1. Okay? So that's going to leave us with 84 x to the 11th, y to the 7th. We're just going to drop it out. So if the exponents are opposite numbers, 5 and negative 5, when you multiply them, that just becomes 0, and that just drops out. Then we do plus, 7 times 3 is 21, x to the third times negative x third, right? This is x to the 0. So that's going to drop out and become 1. 9 and 7 is going to be 16. So y to the 16th. And then z to the 5 times z to the 5 is z to the 10th. So this is plus 21 y to the 16th, z to the 10th. All right. 6. We're going to distribute the 2x squared y to the 6th through. So that's 6. These x's we're going to cancel. And then the y's are going to cancel because they both are given 0. Okay. So it's just 6. And then plus 2 times 4 is 8. Now we have 7 here and 2 there for the x's, so that's 9. 6 and 3 is also 9. And so there's our final answer on that one. Number 7. Okay, same drill. Negative 3 times negative 2 is positive 6. X, there's going to be 6 of them. Y, there's 6 and negative 3. So that's going to leave us with positive 3 when we add the exponents plus. And then if we want to do minus, right? Negative times a positive is negative, so 12, 2, and then 3x's gives us 5, 6y's and 1y, negative 1y, right? Gives us 5 as well. Okay, not like terms, so we stop. Okay, so finding the GCF. So the GCF between any two numbers, okay, is going to be the largest number or letter that they have in common. If it's numbers, you can do it on your calculator, okay? You're going to open up a calculator page, go to menu, number, and you should see greatest common, it could be divisor, and then just type the numbers in and with a comma in between them and hit enter. Okay? So check that out if you want to. You should be able to do it without it though. So if I look here, and if they're letters, okay, you're going to choose the smallest exponent for each variable. So, for instance, if there's x to the 4th and x to the 3rd, okay, between the two numbers, I'm going to choose, I know I want to take out x's, okay, and I'm going to choose the smallest variable. So these two terms, x to the 4th and x to the 3rd, have 3 x's in common, okay? So you can kind of think of it like there's 4 x's here, there's 3 here. They both have 3 x's in common, so that's the GCF, okay? So here, right, we have 2 and 4. So the GCF here is going to be x squared. GCF. All right. In this case, it's y to the 6th, y to the 8th. So that's going to be y to the 6th. Okay. This has 2 different terms. So each term, the x and y, we can take out. Right? The smallest exponent here is a 3. So that means this has 6 of them. This has 3. I can take 3 away from each to be fair. And then this, remember, is exponent's 1. So I can only take 1 y away from both terms. All right. And number 4, the GCF, okay, between 6 and 12. So what's the biggest factor that they have in common? Remember, 6 is 1, 6, 12, so on and so forth. And 12 is 1, 12, 24. And, okay, so the biggest factor they have in common, the greatest common factor, or multiple, that's what we're looking for, is going to be 6, okay? So let's try this again. The multiples of 6 are 1, 2, 3, and 6. And the multiples of 12 are 1, 2, 3, 6, and 12. So the biggest multiple they have in common is going to be 6 from both, okay? So that's what we're looking at when we do greatest common multiple, or greatest common factor. And then remember, we choose the variables. We go with the smallest exponent, so it's x squared, okay? Multiples here between 4 is 1, 2, and 4. 18 is 1, 2, 3, 6, 9, and 18. So the biggest number from those lists we have in common is a 2, okay? And then we have x's, and the smallest amount we can take away from both is 2, to be fair. The largest amount we should take away is both, I should say. And then we have 1y. And for number 6, we have GCF. Greatest common factor is a 2, and then we can take away 3 x's, the greatest amount from each we can take away. Okay, so factoring using the GCF. All right, so what we're going to do now is we're going to do the reverse of the distributive property. So we're going to take this, right? We're going to take this and we're going to break it up. This is a bad example to use here. We're going to take this and we're going to take out the GCF and basically divide the GCF into these 2 terms and end up with that quotient inside, okay? So to do the GCF, all right, from this fraction here, or this term here, 12x to the 5th y cubed minus 18x squared y to the 5th, I'm going to take out the GCF of all the terms. So what's the GCF of the numbers, right? Between 18 and 12, it's 6, and then the variables. So the x's, I can take 2 away. The y's, I can take 3 out. And then I'm just going to basically divide this into the original, and that's going to go inside the parentheses here. Okay? So if I were to multiply this back together, I should get 12x to the 5th y cubed. So 6 goes into 12 2 times. X squared goes into x to the 5th. That leaves 3 over. And these y's, when I divide them out, are going to cancel, and they're going to drop out. So that's why there's not a y here. Okay? Then if I do the 6 into the 18, it leaves 3. X squared into x squared, that makes that go away. And then 3, right? Take out the 5 is going to leave 2 over. And this is what's left. So if you were to distribute, right, this in, you should be able to get that back. So 6 times 2 is 12. There's 5 x's altogether. And then there's the 3 y's. So that's where that comes from. And then 6 times negative 3 is negative 18. Just the x squared, okay? And then the y cubed times y squared is y to the 5th, and that's where that comes from. So that's kind of how you can actually check to make sure you got it right. All right, so let's go through these guys. We got the first one, 5y minus 30. So the GCF here, okay, is just between the 2 numbers because there's no letters in the 30. So that's just going to be 5. That's the greatest common multiple. So I put 1 set of parentheses down. I put the 5 in front. And then I'm basically going to divide the 5 into each term and put the quotient here. So 5 goes into 5y once, right? And there's a y left over. And then 5 divided into the 30 is going to leave me with 6. And that's what's left over. All right. So another way to think about it, right? Now the GCF here between the 2x cubed and the 6x, the biggest number between they have a common biggest factor between 2 and 6 is 2. And to be fair, the largest amount of x's I can take is just 1, because that's all this has is 1. So 1 set of parentheses, GCF out front. And then it's basically like I'm dividing 2x into these, okay? You're not going to show this, but this is what's going on. So if I divide 2x into 2x cubed, the 2x's are going to drop, but that's 1. And then I can cancel 1x here with the 3 here to leave x squared. Then there's a minus because it comes down, because we're taking out a positive term. So 2 goes into 6 3 times, and the x's will divide out. And so that's what I get left with there. And if I distribute, 2x times x squared is 2x cubed, and that's minus 6x. Okay, next one, between the letters. All right, there's no numbers here, so now we just check letters. The biggest name in common is m, so parentheses m. And then if I divide m into m, I get a 1. M into mr is just r. There's my answer. 4, right? GCF here is 5, so 5 up front. 5 goes into 5c. The 5's cancel, and I get c left over. 5 goes into 5d. That's going to drop out, and I get d left over. All right, so for 5, the GCF is between the numbers is 3. Then for each letter, right, I can take out, remember this exponent's 1, that's 1. So I can take out 1a and 1b. So there's my GCF. So 3ab, one set of parentheses. If I divide that in here, the 3's are going to drop out, the a's are going to drop out, and I'll have 1b left over, right? 3 goes into 6 2 times. A and a squared is leaving with an a, and the b's are going to drop out. So that's my answer. Drop out means when I divide this in, it's going to give me 1. Okay? That we don't need it. There's not going to be no b left over after we divide them. Okay, so GCF here between 4 and 8 is 4, and they also have an s in common. And this has a t and an r that are not in common, so that's the GCF. So we're going to take out a 4s. We divide it in the first term, our quotient left over is a t, and the second term is going to be 2, and then r. Okay, 7. So now there's more than one term, so I have to check all the terms. So the biggest number that they all have in common in terms of factors or multiples is just a 2. Okay, they all have an x. The smallest exponent of them is this one. It's a 1. So I can only take one x away from all of them, okay, to be fair. So I take a 2x out. Now, when you do your parentheses, I kind of tend to look and see the length of this and kind of make it almost the same length as the term that's there. So I know I have enough room. So 2 goes into 2x to the 4th. The 2 goes into 4 twice. And then I'll have 3 x's left over, so x cubed. Minus 2 goes into 6 3 times. X goes into x cubed, and I'll have 2 x's left over, so x squared. The 2's will divide out and give me 1. And x goes into x squared, and I'll have 1x left over. And then 2x into 2x is just 1 left over. So if you're going to take this whole thing out when you factor it, you got to leave something in its place. When you multiply it back through, you're going to get that back. So that's why there's always a 1 there if everything comes out. All right, the next one. We got a GCF. Okay, so what do they have in common between 6, 12, and 3? So the biggest multiple they all have in common is a 3. And then the letters. They all have a C. Highest exponent is that one. That's a 1. They all have a D. Highest exponent is that one. Or sorry, lowest exponent. So that's going to be our GCF. So smallest exponents from the letters. And then the numbers is the biggest multiple that all the numbers have. Okay, so we can take out a 3, a C, and a D. And then this goes in twice. There's 2 C's left over. And the D's are going to divide out. Minus 3 goes into 12 6 times. C, 1 left over. And then 1 D. And this, all of this is going to divide into this. So this is just going to be 1. All right, there's 8. So how do we handle this with literal equations, right? So the first thing we're going to do is figure out what we're solving for. And we're going to solve for y. So that means it's in terms of x or y and z. In terms of y and z. That means I want y and z to be on the other side of the equation away from x and z. So I want x and z to end up on the other side of the equation and y to be on this side by itself. So the first thing I notice by looking at this is both of these terms have a y, right? I can't add or subtract them because they're not like terms. So I need to get the y out of both of these terms and by itself. And to do that, we're going to take out a factor. We're going to factor it. So I'm going to take out not just a GCF, right? I don't want to pull anything crazy out. I just want to take the y's out of here. So I'm going to factor out a y, and then just ask what's left, right? Y goes into 4y, and there's a 4 left over. This y goes in here, and there's a 6xz left over. And now I just need to move all this stuff right here over on that side. And since I'm multiplying, the inverse operation, the opposite operation that's going to make this become 1, is division. So I divide both sides by 4 plus 6xz. And so y is equal to 14 divided by 4 plus 6xz. And there you go. All right. So the next one, we are also solving for y. Now the difference with this one, okay, is that when you're looking at this, y's are on opposite sides of the equation. So I know that I have to get them on the same side so that I can factor it out, right? So let's move the 7y over here. So I have 5xy minus 7y plus 2x is equal to 11. Now I could just factor out here right now and leave the 2x by itself. Or if you want, we can get just the y's by themselves first, just the terms of the y. So 5xy minus 7y is equal to 11 minus 2x. And now I'm going to factor that y out. The y is in front. The 5x minus 7 is left over. And then I'm just going to divide out the 5x minus 7 to get the y by itself. And so there's my answer. Y is equal to 11 minus 2x divided by 5x minus 7. Okay? Next question, we're solving for x. So I want everything else on the other side. So I have to factor the x out right away. So x goes into ax. There's an a left over. This x divides in here and leaves me with 1. And then this stuff is just going to stay the same. So I divide both sides by the quantity here, a plus 1. And I have an answer. 34b plus 21c over a plus 1. All right, the last one. Once again, this is on the other side. So we'll do this a little differently than this one, where we move the 2x over. Okay, so here we go. We want to move the cx to this side, so we get the x's on one side. So I have ax plus cx. I'm going to put those in a list together. Plus b is equal to d. Now I'm just going to factor this out right away without moving that back. So factor it out, take the x out. So x comes out, that leaves an a. This x comes out, that leaves a c. And I still have a plus b on the end. So now I need to get the x by itself. So remember, if in order to get the x by itself, I know I'm going to divide this out. I have to move this b over here first. So I'm still going to subtract it. That's why you can move this out before you factor, because you're eventually going to have to. All right? So this is x times a plus c is equal to d minus b. And then we divide out the a plus c. And we get x is equal to d minus b over a plus c. All right, guys, that's it. So just if you haven't, finish this worksheet for homework and have yourself a great weekend. And I'll have you guys a worksheet for you guys on Monday. All right.